My dear students, again welcome to the world of chemistry. You have studied lot of concepts about thermodynamics. Today we focus upon important thermodynamic term, internal energy change, delta U, and how will you measure internal energy change. This is the content lesson 5. Can you give the equation of first law of thermodynamics? Delta U equal to Q plus W. We are applying the condition 1. If work done equal to 0, what happened to the system? That is, no work is done on the system. From the first law of thermodynamics, delta U equal to Q plus W. If W equal to 0, what about the equation? Then delta U is equal to Q. That means the change in internal energy is equal to the amount of heat absorbed by the system if work done equal to 0. Next condition, if delta U equal to 0, what about the term delta U? That is change in internal energy. Delta equal to 0, that is no change in internal energy. There is no increase in internal energy of the system. So, from the first law of thermodynamics, delta U equal to Q plus W. If delta U equal to 0, then Q equal to minus W. That is, work done by the system is equal to heat absorbed by the system. Students, next we pass on to condition 3. Work done is the pressure volume change. If work done is equal to minus P delta V, assume the work done is the pressure volume change and is done by the system. From the first law of thermodynamics, delta U is equal to Q plus W. Substitute for W, P delta V in this equation. Delta U is equal to Q minus P delta V. Now, the process is carried out at a constant volume, that is delta V equal to 0. What happened to this system? Delta U is equal to QV from the first law of thermodynamics. Can you define internal energy change delta U from this equation? Internal energy change is the heat absorbed by the system at a constant volume. That is the equation. How will you represent internal energy change? Delta U equal to QV. That is heat evolved or absorbed at a constant volume. That is the definition of internal energy change. Then how will you measure this internal energy change? Which apparatus is used for measuring internal energy change? Can you name? Bomb calorimeter. What is bomb calorimeter? It is a steel-lined vessel or thermoflask which can withstand high pressure and temperature. Students, let us see the video representation of internal energy change delta U using bomb calorimeter. The temperature of water in the calorimeter is noted and the compound is taken in a platinum cup, is ignited by passing electric spark with the help of filament. Heat evolved is exothermic reaction raises the temperature of water in the calorimeter, which is noted using noted carefully using with the help of thermometer. By knowing the heat capacity of calorimeter, amount of heat evolved in the reaction can be calculated. Since the combustion reaction is carried out at a constant volume, it will give the measurement of internal energy change, that is delta U. Then what is delta U? Internal energy change is the heat evolved or absorbed at a constant volume. That is, amount of heat evolved on combustion using bomb calorimeter, delta U is equal to C into delta T into M divided by W. Students, from this equation, what is C? What is delta T? C is the heat capacity of the calorimeter. What is delta T? Delta T is the rise in temperature. In this e-content lesson, we shall study about thermodynamic function, internal energy change, letter delta U. And how will you measure delta U? It is measured by bomb calorimeter. Study well. Thank you all students. We will meet the next e-content lesson number 6. Thank you.